Okay, so this might be a shorter lesson. The only reason why we have this lesson today is because I wasn't able to complete the whole delivery of all those lessons. There was one lesson that took a little bit longer. So we're just going to carry on. Yeah, we do have that little bit of a cushion of having these days that are designated for tests. However, we compensate that with giving you a little bit more time to complete the test. So I think it kind of balances itself. All right, so the last thing that we have done, and let me just check something here. Actually, no, I'm not going to check it now. But I think that the post-it notes are already available for you for download because I have time triggered them. I think I just left it as is. Were you able to see that? I don't know what, maybe I'm going to check this thing very quickly here. Just give me a couple seconds. Here's our, okay. Oh. Update password, okay. Content. You don't see what I'm doing. I'm just checking if the, just gonna make myself view as a student. I'm just checking if the post-it notes are available right now. Content, students items, 6A6. Oh, that's labs, lecture. Labs. Theory notes. There we go. 6A, 6B starts February 26th. So yeah, so you should have that already available for download. So some of you might have downloaded already. Okay, so we're just going to go over that. So that's the continuing of the PA systems. And last time we have covered the commercial PA systems and constant voltage system. With distributed audio and speakers that tie into the telephone systems and whatnot. Or it could be just a standalone PA systems, could be a background music in your local fast food restaurant or in elevator or in the school, part of the PA system, school PA system, or it could be interfaced with the telephone system. All right, so now we're just going to switch over to the continuing of the public address. Now, this is a different type. Now, let me just see here if I can get, there we go. You can probably see me now in the top right corner. All right, so PA system public address, part 2 of 2. Okay, this wire is just, it's just grabbing the microphone here. All right. So this is this type of public address system, popularly called as stage gear. So some of them are small, some of them are big. This is one of the big ones that it takes a lot of coordination and construction like work to actually set it up for a few days or a couple days or maybe one evening and then tear it down. So some of the PA systems cost more money than others. Okay, so this excuse me, this stage that is temporarily set up, after it's done, it is the same stage. It is going to look like this. All right. So from that to this. Okay. So this is what we're going to cover today. Is this type of a stage gear systems. Okay. Now, what we have here is a typical simplified diagram of a stage gear PA system. My mouse is running on me today. All right, so live performance, typical stage setup. Okay. What do we have here? We have the part that is considered to be on stage. We have the on stage equipment, and we have something that's called front of the house equipment. Okay, all right. So okay, as I was saying, so here's the stage equipment, and here is the front of the house equipment. What is the stage equipment? What does it consist of? We have here something that's called a stage box, or sometimes it's a breakout box. What do we have here? These we have all wires coming in to the mixing board of the front of the house, and then all the wires. So there will be wires that are connected to the input of the mixing. Thank you. Have a good one. We just had the regular Friday afternoon eggs delivery from one of our local farming shops. Okay, there we go. Eggs are good. Anyways, back to the stage here. So what we have here is two types of lines. Some of them are going to go from the stage box into the mixing board, which is going to process all the signal. And after the signal is being processed, the signal is going to be served right back to the stage box and then distributed to the stage equipment, which most likely would be bunch of amplifiers and further signal processors, just to have the amplifiers. Usually we want to have the amplifiers on the stage or close to the speakers or to the speaker arrays or close to the loudspeakers. The reason for that is that speakers, the stage speakers, are usually 8 ohms or mostly 4 ohms. So when you have the wiring going from the stage box to the speakers that are on the stage, the distance that the wire has to cover is minimal. If we had the wires going from the amplifiers that would be placed right at the front of the house, which would sometimes be somewhere close to halfway to the public seats, then the wires would be longer. And if you have something that's like 4 ohms, the speaker is looking for 4 ohms, and the wire itself could have sometimes 1 or 2 ohms of just internal resistance, then the impedances are just too close, and we're not going to have a system that's efficient enough. So usually we try to put the amplifier on the stage, the main amplifiers on the stage, that are supposed to service the loudspeakers that are on the stage. Okay, so we want to have those closest. So that's why we have signal sends and returns from the stage box. So what the stage box is getting the inputs from? Well, it could be getting the inputs from the microphones, from the guitars, keyboards, or whatnot. Okay, so that's where the input is coming through. And what we have here is something that's called like a snake cable, which is basically multi-cable, multi-wire cable in one big jacketing. So this is the analog type of system, still being widely used all over the place. However, the most likely right now you're going to see more and more often, you are going to see the digital systems. So what we have here is we have a stage box on the stage, and instead of, like, for example, if we have a stage box or a snake splitter or snake fan out that is servicing the inputs on the stage, in an analog scenario, we would have a bunch of cables, a cable for each channel. So if it's a 16-channel snake, you're going to have 16 wires, well, 32 wires or conductors, but you're going to have 16 lines, each consisting of the ground reference and the positive terminal. All right, so each line is going to cover one channel, and then you're going to have returns that are coming from the output of the mixing board and physically running. So sometimes you will have 2, 4, 6 returns depending on the stage box that you have that you're using. And the purpose of the returns is that the signal from the mixing board is being returned to the stage box, and from there it's being grabbed onto the further amplification. Okay? Now, that's the analog type of system. Now, when you have digital, you have a digital mixer instead of analog, regular mixer. So in analog, you have every strip, every channel is basically physically there. Yeah. And if you have more channels, you're going to need a bigger mixing board because you need more hardware. Every channel is hardware based. Okay. Now, when we have digital system, you don't need a mixing board physically as big because you could have just like a display window here that is going to display the channels that you are using at the moment. And as far as physical hardware, you might need just a portion of that. And you're going to, with the display, you're going to select which channels you're controlling. So it could be channels from 1 to 16, or it could be channels from 16 to 32, and so on. And these are the channels that are going to be currently on display that you're going to control. Right, so the mixing board is going to be much smaller physically, but that doesn't mean that it has less channels. Okay, and now when it comes to stage box for the digital system, you're going to have a category, maybe Cat 5, Cat 5e minimum, Cat 6 preferred cable that is going to be just one. And then that cable is going to be connected to the RJ45 or the Ethernet type of a port on the mixing board, and all the signals, all the audio signals are going to be processed by the mixing board and by the stage box, and of course from the output and the input peripherals of the stage box. Yes, you're going to have most likely you're going to run the analog type of wires that are going to be connected to the stage box. So, by the same analogy that we had covered in the last some past lectures, this stage box acts as a media converter. It's a type of a media converter. But nobody's calling it a media converter on this. With the stage gear, we're just calling the stage box. All right. Okay. So, what else do we have here on? One thing that I'm going to tell you is that one of the biggest problems that you're going to deal with when you use the analog system. When you use the analog system, one of the biggest problems you're going to encounter is the ground loop noise. Okay, and the ground loop noise basically sounds like a 60 hertz hum, just like a regular buzz from a transformer type of thing, but it can be sometimes amplified. And when that happens, it's a very, very annoying situation, and sometimes it's a very, very stressful situation. That's why when it comes to dealing with the equipment that has to do with the stage, there's an extra attention paid to having wires coiled up properly and stored properly. And cables and wires, that's probably the biggest thing that people take care of, because if you don't take care of your wires, something somewhere somehow might get disconnected, and that is going to give you that annoying buzz. And there's nothing worse that if you're doing a sound and lights, or if you're doing sound for stage production, live stage production, and the show is just about to start, maybe in half an hour, and all of a sudden you get some sort of a buzz coming through the system, and you have maybe 48 or 50 cables or 60 cables to find where the problem is. That could be stressful. So that's why coiling the wires, and maybe on some of the labs I'm going to show you how to properly coil the microphone cable. Right? There's that over-under kind of a technique, the figure 8. So that's if you get yourself hired as a helper in the beginning, or if you're doing the sound yourself, some of us maybe do. Um, you can impress some of the people who hire you by knowing how to coil the wires. So that's basically 100% yes and 100% no. If you know how to coil the wires properly, you're good. And if you don't know how to coil the wires properly, so never do the elbow thing. If somebody sees you doing the elbow coiling thing, you are 100% out. Or someone might just stop, say, don't do it this way, do it that way. Okay. Yeah, there you go. Now, so that's the problem with the analog systems. So there could be an annoying buzz. How to remedy that? So sometimes the buzz comes from damaged wires. Okay, something gets disconnected, lose ground or something, and then bang, you get a buzz. And not that buzz that you want, because some of the buzzes that you do want with sound effects and all kinds of things. Now, one way to remedy that, the other reason that you could have an annoying ground buzz is if you have difference of potentials between the grounds. And that happens when you have a stage gear plugged into the power outlets on the stage. Then you go 100 feet down towards the public seat where the front of the house is. And front of the house is basically where the sound booth is. That's called front of the house. The other one is called backstage. Okay, so now you have everything plugged into the outlets that are on the stage. And then you have the front of the house equipment, mixing board, maybe some effects, other things, plugged into the outlets that are coming from somewhere else. So this stage gear could be plugged into outlets that are connected to one electrical panel somewhere on one side of the building. And the front of the house equipment could be plugged into the outlets that are connected to another electrical panel somewhere on the other side of the building. And just the physical difference in placement of those electrical panels can make enough difference in the ground levels or ground references. Right? Ground should be ground. It's basically they have the different neutral terminals connected to that. And they could be at slightly different potentials, which can cause a huge buzz. So what happens is most of the time, properly, if you are to run a proper sound system, then you get all the power from one place. Usually, it's a power disconnect, a high power outlet. Backstage, 60 amps, 100 amps, okay? And then you get something that's called a distro box, and distributor box. Basically, you connect, you connect, and sometimes you need a licensed electrician to connect that thing for you. And if you become licensed electrician, you can do it yourself, providing you fill out all the paperwork. Then you connect that power service to your distributing box, or sometimes called distro. Okay. And from there, you get all the power outlets, the 110 outlets, 110 volts, AC. You plug in all the stage gear in there, and then you run an extension cord, a portable cord, right to the back of the, public, where public is called front of the house, usually halfway through the public seats. This way, you're making sure that you're running everything from the same electrical panel, and you get a nice clean sound. Okay, so that's the troubles that you can get with an analog equipment. The other troubles that you can get with an analog equipment is if you have impedance mismatching. Okay, impedance mismatching. What can I say? Or actually, if you get a weak signal, no, back. Balanced versus unbalanced signal. Do we remember what we did when we explain, remember one of the lectures we explained, we covered what the difference is between balanced and unbalanced signal. I'm just going to review that for quickly here. So here is an unbalanced signal. You have a ground reference, right? And you have a positive signal. So here's the ground reference, and here is the positive side. Ground reference is a ground reference, and this is where the signal travels. Right? Usually, it's called a line level signal because it's good for line level signal. Line level signal comes from higher output devices, such as, well, powered, such as keyboards, anything that's powered, okay? So you get something like maybe 1 volt peak-to-peak signal. Right? And the impedance of that would be something like 600 ohms. You don't have to remember this one. Okay? Well, the exact values here. But if you're going to be in the business, you're going to remember some of that, right? So 1 volt peak to peak on one line. If you have tiny bit of a noise, it's going to just kind of disappear on that within that waveform, and it's going to be barely noticeable when the whole rock and roll band is playing or whatnot. Yeah? Now the problem, well, you can transport a signal like that, well, maybe 100 feet or so. Okay? Now the problem is when you have signals coming from low power devices, passive devices, such as a microphone. You don't plug in the microphone unless it's a condenser microphone. But usually the dynamic microphones, they are basically it's a piece of equipment. You plug the wire in and you speak to it. Okay, so it's a passive device. It's not powered. Okay. All right, so now the signal that is coming from a microphone, instead of being 1 volt peak to peak, is well, maybe 1 millivolt peak to peak, up to maybe 10 millivolts peak to peak, depending on how strong the signal is. Okay, so when you have 1 millivolt peak to peak signal and you have a noise that some sort of a car drives by that has a bad ignition there, then the noise is going to be comparable to the signal. And basically the ambient noise of electromagnetic interference, you're going to hear a hiss or a hum or a buzz. So that's not good. And you still want to transfer the signal of over 100 feet. So what happens is we use the balanced signals, which has a ground reference. So here's the unbalanced. And this will be the balanced signal here. So you have a, well, let's just make it a little bit lower here. Okay. We have a ground reference. Okay, and we have the positive, and we have the negative reference. Positive and negative reference. So when a signal comes from the microphone, it goes like this on the positive side, and on the negative side, it is 180 degrees reversed. I'm drawing it in phase. You get the idea. Okay. Let me just do it properly. Okay. It's Friday. Okay, so this would be something like this, and here, and here. See that? So those signals are 180 degrees out of phase, and and at the other end of the line, what receives the signal is something that's called a differential amplifier. And what differential amplifier does is it passes the signal through if it has two signals and they are 180 degrees out of phase, so they're opposite. Okay, one goes up, the other goes down, and they are mirror image of each other. Then it's acknowledging the signal as a signal and it passes it through. anything that is in phase is going to be ignored by the differential amplifier. So if you have some sort of like lightning strike somewhere nearby or further down the road, you're going to have a spike, but those two spikes are going to be in phase. And when they're in phase, those are going to be ignored. So if you have any kind of noise riding on that, that noise also going to be in phase with each other, and that noise is going to be ignored. So that's why balanced signals are quite efficient. You can carry a microphone signal that way, 100, 150 feet or so, and still have a nice, beautiful, clean signal, right? All right, so that's the difference between balanced and unbalanced signal. And the balanced signal, the balanced unbalanced jacks are basically those guitar banana plugs. They're called quarter-inch jacks. They look like a guitar plugs. And the balanced jacks are sort of like they look like this here. It's a circle with 1, 2, and 3, and they're called XLR. Okay, there's an XLR, and the other one would be quarter-inch jacks. Okay. I invite you to watch some of that or research that maybe on Google or whatever else if you're interested in exploring this topic further. Okay. So here is the balanced and unbalanced signal. Now, so we talked about the troubles that you might encounter, some of the basic troubles that you might encounter while using the analog signal transmission when it comes to stage gear. So most of the time, you're going to experience an annoying kind of a sound. Now, when we are dealing with digital signal transmission, remember when we have this, where's that here? If this is a digital stage box, right here, we're not having 16 channels, one wire or one cable per one channel. We're going to have only one category cable, Cat5e or Cat6. And all the signals, all the channels, all the sends and returns are going to be processed by that one Cat5e cable. So what happens when something goes wrong with that digital Cat5e cable, it's not going to sound like an annoying buzz. It is going to sound like the world is coming down. So it's going to sound like the end of the world, and it actually can damage the speakers. All right, because it's just the sound is just terrible. It's loud and sudden and harsh. Okay, so that's the downside of using the digital system, is that when it goes wrong, it really goes wrong. Okay. All right, so I have here's something here, Philip. I have done that with my guitar cables for years. I'm sorry, you must have sent that chat some time ago. Which part you were referring to? I should have seen that. I apologize. I should have seen that chat line a little bit earlier. So let me know what you have done with your guitar. Okay. So it's nice to see some musicians. I've been on the stage for years myself. It's a nice trip. Okay, not really COVID friendly, because when you have COVID, you can't have public. All right, so let's keep going with this. Also, what we have something on the stage is monitors. What are monitors? Monitors are a hearback reference for the artists to be on the stage. Now, there are two ways of solving that equation. You could have the traditional way where there would be speakers on the stage. Basically, they're this shape. Okay, So they're sitting on the floor, and here will be the loudspeaker pointing at basically at the face of the artist. So through that, you can have something like a monitor mix. So this main mixing board can serve as two things. It is possible to use the main stage or the front of the house mixer to do the front of the house mix, which means you're mixing the signal levels and the signal quality to accommodate the sound that is supposed to come through from the main speakers and hit the public. Okay, so that's the front of the house mix. If you are dealing with the stage monitors, you're going to have the stage mix or monitors, stage mix, monitor mix. You could have output channels from this mixing board designated to accommodate a bunch of other amplifiers that are servicing those stage monitors. Right? And that is very difficult to accomplish, or somewhat difficult, although a skilled technician can accomplish that. You adjust a separate mix that goes to the stage monitors. And those speakers contain certain levels of instruments that are supposed to be servicing the artists that are on the stage. So if there is a person standing at the microphone, by the microphone here, main microphone, playing a guitar, that person might want to hear the keyboard a little bit more, or they might want to hear the other guitar a little bit more or less, or something like that. Okay, and maybe a little bit. So there is a separate mix. Now there could be another mix, another channel that is servicing another guitar player, and that guitar player might want to hear some other instruments better, or some other instruments less. So there could be, sometimes if you're in a pinch, you can just use one channel and everybody has to suffer through because it is what it is, and you just have that what you hear on the stage is not what you hear at the front, but that's the life of an artist. Okay, but with some more sophisticated or more advanced systems, not that advanced, but advanced than the not advanced ones. All right, you're going to have more than one monitor mix, okay, on the stage, and so different people can hear the instruments shooting at them through the speaker at the different rates and different proportions. Okay? Also, there's a third kind of a mix that you can have, and there will be some, which is not here. There will be speakers on the side of the stage, and they just provide an overall type of a kind of a fill-in type of a sound, so the people on the stage can feel more comfortable playing the concert or whatever is happening, and they're called the stage fill monitors. Okay? So that's the way the monitors are being done. Now, another way of doing the monitor mix would be having a stage box that would be a split signal box. So every channel that goes to the stage box is being split. Part of the signal goes to the front of the house mix, and half of the signal goes to another mixing board, which is not here, another mixing board that would be almost, can be just like the other one, that could be on the backstage. So this and those two halves of the signal are sent independently and dealt independently by the front of the house. So the people at the front of the house, they don't have to worry about what's happening on the stage monitor mix. They just care about how the sound is supposed to be sounding properly at the front of the house, through the front of the house speakers, to the main speakers. Okay, and that's the best way of doing it. Then there will be another person or two sitting at the backstage mixer, the monitor mix, and they will get the signal, half of the signal from every instrument or microphone to their mixing boards, and they would be servicing they would be doing a stage mix, which is much better because if somebody wants to communicate with the person to give them a little bit more hearback on instrument or two, they can just kind of come over towards the person who's basically sitting at the side of the stage, and they can communicate with them easier instead of having to, sometimes giving some hand signals or something to the front of the house guy to give them a little bit more piano on the monitor. Okay, so that's one way of. Well, there's another way of doing it. Now, another way of doing this monitor mix is something that's called the in-ear monitors. In, as in going in, and ear. All right. So there would be sometimes you're going to see in some live concerts, there would not be too many speakers on the stage. When you see some of the older concerts from 70s, you're going to see a bunch of those stage monitors all over the stage that are giving the servicing the artists on the stage. Excuse me. But right now, you're going to see in some of the modern concerts, you're going to see people wearing something like that looks like a hearing aid that's deep in the ear. So what happens is that there's a separate stage mix or the monitor mix being done by separate people, and that only goes to the in-ear monitors that are basically the stage artists on the stage are wearing those. Okay, so that's as far as the basic setup on the stage. Okay, let's just take a quick look at a mixing board. This is the simplest mixing board that you could probably find. Right now, this might set you back about $100, or maybe even if you search well on Amazon or whatnot on the internet, something like that might cost you about $65 or something like that. So not a big deal. They're cute little mixers. But we're just going to take a look at what the mixing board consists of. Okay. All right, so right now we're going to zoom in to just this part right here. Okay, so that's the part right here. See that? Those two microphone outputs. All right, so see, this is what the balanced, the top left ports are for balanced signals jacks. Yes, exactly. There you go, Tyler. Okay. So this would be the XLR inputs, the balanced inputs, all right? And now for this channel, okay, so this is a 2-channel, 4-channel mixing board, but you can have 2 balanced inputs on this one here. So you have, excuse me, you have the microphone inputs that you plug in the microphones here to this one here, or you can plug in a line level signal right in here. Right, which is the 1/4 inch, like a banana plug. So basically the internal structure of this 1/4 inch input is that once you plug this one in, that one is automatically disconnected. Right? And then you have line or high impedance. Right? Sometimes it's called a pad. Okay. So it'll be a line level or microphone level signal. Okay? So if you have a weak signal coming from a microphone, you would select this high input here. Okay, the high sensitivity input, which would accommodate the microphone. Right, and if you have something like a keyboard that's being connected to either one of those, you can take the pad out, and usually the pad takes the signal down or up, not up, like it will take the signal down 20 dBs. Okay, remember 3 dB is half the power, and if it takes 20 dB, that's, you can just do the calculations here. Okay, so just depending on what kind of a signal you have, a weak or strong signal. Strong signal would be something from a keyboard, which is an active device, which is plugged in, or a CD player, or whatever the DJ gear that is powered up. So that would be the line level signal, which would be about 1 volt peak to peak or so. And this microphone level signal would be something from, well, mic level, okay, which would be about 1 millivolt peak to peak. And yes, of course, it is possible to have a line level signal in a balanced way as well. All right, so that's the pad button is quite useful, because you're going to, if you have a too strong of a signal or too weak of a signal, you just press the button to accommodate the signal level that is coming into the mixing board. This other channel is just the same. Now here is monitor send. So this is an output from the mixing board that is going to send the signal to the monitor mix. Okay, and then and there is going to be a separate slider that accommodates this. My mouse keeps disappearing. Is going to accommodate this output. All right. Now you have the main output right here. All right. So it will be left and right. So this would accommodate the front of the house. Right? And then you have something that's called a mono or stereo. Well, I can use it as stereo. These are the mono inputs left and right, or you can just have maybe a keyboard that is in stereo. You can plug it in, and you also have a separate slider to accommodate this. Or you could just have separate channels on these. So you could have 1, 2, 3, 4 channels on that. Here's a monitor send, so that would be the output that sends the signal to the, you could use it for the monitors. And here is the effects send that, well, we'll deal with that. Yeah, we'll explain this thing a little bit further down the road. And then you have tape in and tape out. Well, quite often, when I display this slide, people ask me, what's tape in and tape out? Well, that's it's one of those things that that makes me feel, makes me feel my age, because there's, there are people that were born that are old enough right now that they don't know what tape is. Well, tape is basically a tape deck, all right, or a tape device. Before there was the devices were digital, like MP3 players or digital audio recorders or digital players. The recorders or players you would use a magnetic tape as a medium, okay, to record the signal on. Right? Yes, sad times, okay, and that would be the either the reel-to-reel tape, which would be like a reel of tape and another reel of tape on the equipment, and the tape would run through the magnetic heads to basically either record the sound onto the tape or read that recorded sound from the tape. And the terminology has stayed, but this is basically where you connect your MP3 player or a CD player or whatnot. But the terminology has stayed as tape. And of course here, headphones, headphone output, so you can hear things. Right? All right, so now we're going to go back to the main view here, and we're going to take a look at some of the strips. Here will be the 2 input strips. Right? So here is the top part that we just looked at, and over here we have, you know what? You zoom in a little bit. Okay. So we have the microphone inputs, and over here we have something that's called a gain. All right, so that's the first stage of the amplification of the signal. You are adjusting with the gain knob or potentiometer. You are going to adjust the gain of the incoming signal So you're going to have a comfortable way of maneuvering this main volume for this whole strip. Okay, so you're setting up the levels for the comfort of this volume control that is servicing this whole strip. Mixers are supposed to be versatile. Anything should should be able to plug in any kind of a signal. That's what's making a professional stage mixer. Right? Right. And now over here you have a little button that says low cut. Right? Usually it's below 80 hertz is the threshold. What that is that when you plug in an instrument like a keyboard, for example, or guitar or bass guitar or whatnot, that is supposed to use the full spectrum of the human hearing range, which would be 20 hertz to 20 kilohertz for us humans. Animals go higher or lower sometimes. So anyways, the problem with doing a large stage mix is that you have so many sources, so many microphones, and sometimes when you have too many microphones and they're turned up too high, you get something that's called a feedback loop. It sounds like a large howling kind of a woo kind of a sound, right? Basically, the signal from the microphone is being fed to the mixing board, and the mixing board feeds things to the amplifier. Then the speakers amplify that. The microphone picks it up again and makes it even louder. So it's called a feedback loop. And we don't want that. It's an unwanted thing. So if you have instruments that are supposed to be using full spectrum of the sound, and you're not going to have a feedback from a keyboard because it's a direct in. Okay, so it's not going through the microphone. The signal is going directly in. So there's pretty much little chance for things to feed back to the front of the house and to the microphones. I can see. I'll get to you in a second here. So you can undo that button. You're not going to have the threshold. So you're going to transmit all signal through that input. Now, when you have a microphone, human voice doesn't go that low to 20 hertz. Okay? So the human voice is roughly, around 80 hertz and up. You're not going to have a 20 kilohertz human singing like that. It will be something quite unusual. But sometimes when you plug in the microphone, for human voice, you do not need to amplify the low signals because they just don't exist in the human voice. So that gives us a little bit more playroom to maneuver with the volume, because when you have too much volume, some of the low signals can feed back and they're useless when it comes to human voice. So you can just cut them off. So that's basically what that is. It's a low cut button here. Now, in this mixer here, you have a little tiny EQ, and this one will just give you the highs and lows. Yeah. So basically, it's setting the tone when you want to make the sound tiny or thick. All right. There's a thing here for this mixer. Is channel 3 and 4 sharing one column? Well, we're gonna take a look at that. So after we do this thing here. So here's auxiliary. All right. So here is for the monitors. So it looks like here's the volume control for the monitor. How much of the signal you want to send to the monitor output. Okay. And over here, you have how much of the signal you want to send to the effects output. So each individual signal can send just individual amount of signal to the outputs right here. Okay. So this would be the monitor, and yeah, it will be the monitors. So you just use the mono, or so 3 and 4. Let's see, here is the 3 and 4 channel here. Let's take a quick look at the main All right. All right. The main part of the mixing board here. In this one, channel 3 and 4, it's hard for me to say if this is sharing the one column here or not. You know what? I'm not sure with this mixer. All those small mixers are sometimes different. So here's the mains out. Here's the left and right for the monitor. Here's the monitor. Here is the input. So left and right. Yes, they will be sharing that one column right here. Yes. Okay. It's going to share one strip. All right. So yeah, it's a small mixer. Okay. Let's keep going with this here. Go back to the show. Come on. Now, what we have here is the outputs, right? Now you have the common little type of a equalizer, the graphic equalizer, so you can boost or subtract some of the frequencies that are being sent to the main mixing, to the main mix. And usually you do not want to add, if you want to do things properly, you want to have something like a flat, and then you're going to subtract things. You want to do less than more. But sometimes you're going to have things that are, you're going to have the things that are you might want to add some frequencies. Okay. Now there's a bit of an effect. Headphones output. Here's the main and the monitor output level. Very simple little mixing board. Okay. Now here's the bigger mixing board, which is basically more of the small one in one piece. Instead of having 2 or 3 channels, this thing is having, I think it's a 48 channel or 24 channel. Yeah, it's a 24 channel mixing board. So it's just more of the same thing and just stuck together. And usually you're going to have similar things that are on the output. All right. Now, here is remember I was talking about the digital mixing board. Now, when you have downloaded the PDF version of this, you can click on this link here to just see a little bit of a demo here. Now, this is Yamaha CL5 digital mixing console. I'm not sure how much this thing costs right now. I think it's something around $40,000 or maybe more, or maybe I don't know, something like that. You might want to check the prices, but this is a serious piece of equipment here. Yamaha CL5 Control Logic 5 digital mixing console. And this, I think this is, I'm not sure how many channels that one has, but it has a lot of channels. So what happens is you have here the digital display, which basically is displaying the sliders. So you can call up sliders from 1, 2, 3, 4, 5, 6, 7, 8, or whatever. And it's going to display channels maybe from 8 to 16 and so on. So then you can still control this thing manually, but you don't need as much physical space because with the display, you're going to shift which channel range you're going to control. Right? Fully digital has effects built in. A lot of effects. You're going to have limiters, equalizers, feedback destroyers, microphone processors, digital reverbs and delays and all kinds of things, compressors. It is all in there. Okay, that's why this thing costs so much, because if you want to have this thing in an analog form, you're just going to have to build everything physically. If you need maybe a microphone processor or something, you buy a piece of equipment. You need a reverb, buy a piece of equipment, and so on. Okay. So things are a little bit different now than what they used to be. Yeah? And I encourage you to watch this YouTube video just to see how things work. I'm just going to give you a little bit of a kind of an overview, something like a trailer of a movie. Now, if you if you're interested in pursuing your career in this type of field, there's a program here in our college. It's called Music Industry Arts, and you might want to investigate that. Now, where am I here? There we go. Let's keep going. Also, okay, so that this digital mixing board, of course, it uses the stage box or multiple stage boxes on the stage, and which are connected to this mixing board through Cat5e or Cat6 cables. Also, what is really popular these days, if you have smaller venues, you are going to have a stage gear right on the stage, and you're going to have wireless connection for the control devices. So that is also the way to go today, right? Also, what happens, depending on the system that you have, you can see the stage monitors here, all right? There's no in-ear monitoring system. So this would be the front of the house speakers, and over here, and this will be the stage monitors. Okay, quite often depends on what system you have. If somebody wants to hear things on the stage for the stage monitor, there are devices like a tablet or cell phone. A cell phone can be connected to it as well. So whoever is sitting at the microphone there, they can control their own stage mix that goes to the monitor. Now let's talk about some microphones. Okay, the microphone is a transducer. As we remember, what does transducer do? Transducer converts one form of energy into another. Okay. So the microphone, this is something that's called Shure SM58. Okay, right here, SM58. That's what this SM58 looks like. I'm going to say that, look you straight in the face, and I'm going to say, this is the best microphone, stage microphone in the world, period, of all times. All right. Again, Shure SM58 microphone is the microphone to get. Right now, it costs about $120. Right? And if you are planning to do any kind of a stage mix, that's a bold claim. Yes, it is. There are some people who prefer different microphones, but you know what? If you have a choice of getting one piece of equipment for a stage mic, vocal mic, Shure SM58 is the one. The best in the world ever. I think they started building it in 1967, and it's still going good. All right. Now, this is not so happy phone ring. All right, thank you. Now, over here, you're going to what makes it such a good microphone? It's basically the way it's made. What can I say? When you're working on a stage with different kinds of equipment, you're always going to go back to that Shure SM58. And after a while, if you get, as you go gaining your experience on it, you're just going to know that this is the best microphone as far as feedback versus frequency transmission, the best sounding microphone, the most comfortable to work with, and really, really tough. Okay, you can use it as a hammer. Not really, you don't use it as a hammer, but almost. Okay, so that's the higher quality like Sennheiser. Sennheiser is a pretty good company, but you know what? Shure was first. They did that. SM58. They came up with the SM58, and there are some microphones that some people would prefer, Sennheiser or AKGs sometimes. No, but I'll tell you, if you work with the stage gear, you're going to find that the SM58 is going to be the best. Period. That's it. So that's mostly used for vocals. And the way you use this microphone, you almost put your mouth, almost pretty much, some people are just touching this microphone head with their mouth and they can scream to it, and that sounds good on the stage. Right? Now, here is the YouTube link here that is comparing the Shure SM microphones. I encourage you to watch this while wearing headphones, because you're going to get the best benefit of the sound differences that you're going to hear using Shure SM57, SM58, and SM7B. Okay, now I'm going to tell you this, and you may want to write it down or just remember that. SM57, you're going to watch this. SM57 is best for amplifying instruments. You have a guitar, you put SM57. You have a trumpet, nothing else, you're going to put SM57. You have regular drums, even the overhead, you can still use that. Then you're going to use SM57 for instrument. Okay. For vocal, use SM58. Stage. Now, when it comes to studio environment, you would probably, out of these three, you would choose SM7B. Okay. So again, wink, wink. All right. Get it? Get the message? SM57 for instruments, SM58 for vocals, SM7B, it could be instruments or vocals in the studio environment. But I encourage you to watch this, and you're going to see how different the sound comes from. I know there's subtle differences, but they are. What's the next slide? I'm curious. Now, here's also another YouTube video that compares different microphones. Now, it is okay to see this YouTube video, and you're going to, for this one here, you just watch that, and you're going to hear the difference between different microphones here. For vocals, these are the strictly vocal, stage vocal microphones. And one of them is Shure SM58. Now, when you're listening to that demo, A and B comparison, but because they're using that in the studio environment, just to get the best type of signal transmission that goes through that, just to see and compare how different microphones sound. Right? Still, even if you are going to see some of the other microphones sounding pretty good, and that might be your choice sometimes if you do sound on the stage or in the studio, you might want to work with other microphones. And sometimes some of the sound people can be weird in a good way. Okay, that some people there's one piece of equipment that somebody prefers, they work best. You know what? That's okay. That's how they work with the equipment. Right? That's their preference. Right? But then again, even though you might not get the feel of how different those sound really, unless you start working with them on the stage and you're dealing with the signal levels, with the feedback, with the comfort of using it. I think you still might want to consider that. But then again, if I keep talking about that, somebody might accuse me of indoctrinating, which I'm really not trying to do that. Basically, what I'm going to say, work with it in the field and talk to me later on. Okay. Now, balanced and unbalanced signal, we just covered that in the beginning of this lecture. Now here, I think it's the last slide, is it? Yes, it's the last slide. So we're not going to take a break. We're just, this is a shorter class today. No, come on. Let's take a look at just a simple audio setup. It's an example here. So here we have the mixing board, right? What we have here, we have some microphones here. We have some other microphones here. We have, oh, look at that. We have the other audio distributed system that is coming out of the 70-volt amp with the volume controls and the constant voltage speakers with the transformers on. And then we have some signal processing, and then we have the main speakers, and maybe we have some other speakers here for monitors, stage monitors or not. And there's a, now just by looking, oh, there's a digital recorder or signal processing type of equipment here. Now, I'm not sure if how clearly you can see this by the time it gets to you through the Zoom channels. Can anybody just have a guess of what that could be? What this system could be? Any guesses? What type of a system? What type of a scenario this is that we're looking at? I hear crickets. As in topology? No. As a type of a system. School could be. I'm not sure how clearly you can see because you're gonna have to say, yeah, it's a PA system. Studio. Thing that gives it away. There you go. Here is the $100 price that I don't have to give. The choir mics that they give away. All right. So that would be a typical church audio system. So here's the mixing board. Right. Here are some wireless microphones for the priest or minister to wear. So these will be wireless receiver, and they will have the belt packs with the wireless transmitter, which are connected to the microphones. This will be the choir microphones, condenser mics. That will be the. I encourage you to. Well, we don't have time to go over this, but on your own, if you're interested, research what the difference is between a condenser mic and a dynamic mic. Okay. Now. This would be the podium mics or the lectern mics. This would be the choir mics overhead. And over here, this would be the system, constant voltage system that goes in the hallways, or maybe something that's called a crying room. A crying room is in the church are very popular rooms. Simply because there could be a congregation of 200 people sitting in the church, and there's somebody with a baby, and the baby starts crying, wah, 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 oh, they can't have the service. So that's when the mom picks up the baby and goes to the crying room. It's called crying room for the babies, and then still she can hear that the whole service, and it's usually behind the glass or something, so the service can be still heard over the PA speakers right here. Okay, so that's basically the whole setup. Any questions about anything that has to do? Oh, this was just kind of like an overall tasting platter of what the what sound systems are. We have covered the public address as far as the commercial setting, as far as just the audio distribution source, like the school PA speakers or telephone system PA speakers and horns. And we just covered the stage gear right now. Any questions about anything that we have so far, or maybe the test or whatever? So we're just about to wrap up for today. Can we expect PA system questions to be on the test? Yes. So the test, when will be the test open? The test I will open probably later on tonight, towards the evening. And when will it close? Let's see. Let me take a look at the calendar here. Just gonna take a look at that. Or should I just show you the courtesy of looking at the calendar here? Okay, let's see. Today is 12th. Tomorrow is 13th. So Friday 13th, this month is on Saturday. Okay, let's give you here Monday, Tuesday, one. You know what? Oh, I just give you a whole week to do this. You want a whole week to do that? See how that goes. Yeah, all right. Hopefully, it's the thing is that because we're doing the online testing here, I'm designing the questions a little bit different, and as you have noticed from the test one, you have all the resources. You have the possibility of communicating with each other. You have the possibility of Googling some of the information. You have the videos. You have the post-it notes. So of course, I had to make the questions with a little bit more detail. So you have to look for the answers because we're not sitting in the class. If it was just in class on paper test, the questions would be different because I have to kind of accommodate. I can only expect you to remember so much. However, this online test is basically when you're looking for the answers, you are also learning as you are doing it. So here's the intrinsic motivation type of a speech here. Do not cheat, because if you cheat, you only cheat yourself, because I know how to do this. And if you cheat on the test, you're going to get some good answers. You're going to get some good mark. But if you go to work, you will not know how to do the job. And that's when you're going to go, oh, darn, and bless you. So there you go. That's about it. I mean, not not complaining. No, I know you're not. So that's my kind of like a vent by the river motivational speech here, as I sometimes do one of those. Okay, if there is nothing else, expect the test to be open sometime in the evening. And I will see you when I see you during those labs. Okay, thank you. Have a good one.